Good day everyone! I am going to discuss induced nuclear reaction and nuclear fission and reactions. For the objectives to discuss the induced nuclear reaction, to define nuclear fission and reaction, and calculate energy release. In 1919, Ernest Rutherford was able to accomplish transmutation of nitrogen into oxygen at the University of Manchester using alpha particles directed to nitrogen. This was the first observation of an induced nuclear reaction in which particles from one decay are used to transform another atomic nucleus. So an induced nuclear reaction is a reaction that can involve more than two particles colliding, but because the probability of three or more nuclei to meet at the same time at the same place is much less than for two nuclei, such an event is exceptionally rare. A nuclear reaction is semantically considered to be the process in which two nuclei, or a nucleus and an external subatomic particle, collide to produce one or more new nuclides. So now we are going to discuss nuclear fission. Nuclear fission is a process by which the nucleus of an atom is split into two or more smaller nuclei known as fission products. When an atom is bombarded by a neutron to produce an unstable isotope which undergoes fission, neutrons are released during the fission process. They can initiate a chain reaction of continuous fission which sustains itself. Fission is the opposite of fusion and releases energy only when heavy nuclei are split. So now we are going to calculate energy release in nuclear fission and reaction. So now let us calculate energy release in such nuclear activity. Given this, mass of uranium is equal to 235.0439. Then mass of krypton is equal to 88.91784. Then mass of barium is equal to 173.327 U. Then 1U is equal to 1.6605 times 10 raised to negative 27 kg. So now we are going to add the mass of the products of krypton and barium, or we can also call daughter nuclei, which is 226.244.84 U. Then we are going to subtract these to mother nuclei, or the mass of uranium, which is the 235.0439. So if we subtract the mass of uranium and the sum of krypton and barium, so 235.0439 minus are subtracted to 226.24484 is equal to 8.79906. So now we're going to convert this extra atomic mass unit into kilogram, then calculate the mass energy. So 8.79906 U times 1.6605 times 10 raised to negative 27 over 1U is equal to 1.46 times 10 raised to negative 26 kilogram. So for finding the released energy, we can use this formula. E is equal to mc squared. So let's substitute 1.46 times 10 raised to negative 26 multiplied to 3 times 10 raised to 8 close parenthesis squared. So the answer is 1.314 times 10 raised to negative 9 joules. So, since energies in atomic level are in small numbers, we usually express them in electron volt. Thus, 1.314 times 10 raised to negative 9 joules multiplied to 1 electron volt over 1.6 times 10 raised to negative 19 joules is equal to 8.21 giga electron volt, or 8.21 times 10 raised to 9 giga electron volt. Or we can express as 8.21 giga electron volt. So let's move on how to calculate energy release in the following spontaneous fission reaction of uranium that yields to strontium plus xenon plus 3 neutrons, which is strontium have 95 atomic mass and xenon has 140, and there are 3 neutrons. So given the atomic masses to be mass of uranium 238 uranium is equal to 238.050784 U, and the mass of 95 strontium is equal to 94.919388, and for the mass of 140 xenon is equal to 139.921610 U. And last, for the mass of neutrons is equal to 1.008665 U, or 1.008. So now we are going to add these 3 fission products, which is strontium, xenon, and neutrons, then subtract to the mass of uranium which is 238.050784. So, the sum of the total of the three is 237.86693. So, as always, the energy released is equal to the mass destroyed times c squared. So, we must find the difference in mass between the parent 238 uranium and the fission product. So, we're going to subtract the parent to the daughter. So, the parent is the uranium that has 238.050784 subtracted to the sum of the three masses product, 237.86693. So, the answer is equal to 0.183791 U. So remember that one atomic mass unit is equal to 931.5 mega electron volt. So the energy release is calculated given this formula. E is equal to the heat of the mass close c squared. Then let's substitute 0.1837791 U multiplied to 931.5, oh I forgot, 931.5 mega electron volt over c squared over U is equal to 171.2 mega electron volt. The 171 mega electron volt energy release is large but little less than the earlier estimated 240 mega electron volts. This is because this fission reaction produces neutrons and does not split the nucleus into two equal parts. Thank you for listening.